the point-slope form of a linear equation. We saw in the form y equals mx plus b that b was the y-intercept and that m was the slope, right? And the y-intercept, this b, was actually a point. We could write it as a point of x equals 0, comma b. This x 0, b into the y. So this point is on the line. It's not only on our line, but it also is on the y-axis. All right. We also saw that we could start at this point and use the rise over run idea of slope and find another point and then draw the line. All right. We saw that in the slope-intercept form video. So all we really need to draw a line are 2 points. Right? We could have 2 points. Let's draw a line. We could have any 2 points in space, and we could draw a line. Let's see if I can draw a line. Well, almost. Beauty of technology is we just simply move the point. So 2 points in space, I can draw a line. Or, not a very good axis here, or I could have a y-intercept and a slope, so I'd know I need to move up, say, and over, up, and over. If I knew that slope, I could then also draw a line. Okay? So either of those will give me enough information to draw a line. So we had the y-intercept and a slope. We could form a line, but it turns out we really don't need the y-intercept. We could have any point on the line, right? I could take a point here, say, and let's say that was on a line. And if I knew the slope, I could start from this point and simply put in my slope, right? And then I could form a line from that. Let's take a look at this in a little more detail in terms of the algebra associated with that. Let me draw another line for you. So here's my x and y coordinate system, Cartesian coordinate system, and here's a line on that system. And let's just pick a point on the line. All right, I'm going to pick it right here, and I'm going to tack it there. I'm going to draw a little tack here, if I can. So that's a tack. Boom. This thing is in, and it's not moving. I've tacked it in place. It's never going to leave. All right. Now let's erase that. It looks like a little strange thing. All right, and I'm going to call this point, I'll give it a name because it's just an arbitrary point on the line, but I'm going to put it in place, right? I'm going to tack it right there. So I'm going to say it actually has numbers, x1, comma, y1. It has a coordinate and it's on the line. And then what I'm going to do is pick another point on the line, but this point is arbitrary. This point could be anywhere. So I'm going to say it's on the line. It looks like it's here, but I'm going to draw little arrows saying, you know, I could pick this anywhere up here or anywhere down here on the line. This point can move. And because it can move, it's somewhat variable, right? I know it's not, the only real restriction is that it's on the line. And I'm going to call this point x, comma, y with no subscripts because it can move. So these are somewhat variable. Because I have 2 points on the line, I could figure out the slope, right? The slope is the rise over run, right? The change in y over the change in x. So let's do that. Let's say slope. This is the change in y, or the rise, over the change in x, or the run. And I'm going to call this, let's put some values to these points. Because these are subscript 1, let's call this point number 1, and let's call this point number 2, because we also know for slope it's y2 minus y1 all over x2 minus x1. Right? That's just the formula, where these subscripts have to do with the points. So let's plug those in. Well, y2, I come to my second point up here in orange, and I find out that its y value is y. Okay? And I'm going to subtract y1, and it has a value y sub 1. And that's divided by x sub 2. On my second point, the value for x is just x. And the value in the first point was x1. So that's my slope for this particular line. Now remember, my variables are x and y. This line is set in space. It's not moving, it's there. It has a specific slope. It has a number associated with that slope. It has a point, x1, y1, that I've fixed in place on this line. So the variable is that second point. It could be anywhere along this line. So now I have a formula that I can use. I can use everything we've learned in algebra so far, right? So I'm going to put this in parentheses because that division bar means a grouping, and I'm going to multiply both sides by x minus x1. And it's x minus x1 over 1, right? Because I'm multiplying. And I'll do the same over here, x minus x1. It's an equation, so I can multiply both sides by the same thing. And notice that these on the right-hand side will cancel. And I'm left with x minus x1 times m is equal to y minus y1. And if I switch the sides, right, if I just switch everything around, and because this equal sign, I could read it from the right-hand side to the left, I'm going to change this and say this is y minus y1 is equal to m times x minus x1. Right, because everything commutes and I've got the equal sign to work with. This particular form is called the slope. We've got the slope and a point, x1, y1. So we call it the point slope form of a line. Just another form of a straight line. So m is the slope. And this point x1, y1, comma, is the point. So we do have a point in math. So let's look at some examples of this. I'm going to write it down again, the point slope form. You need to memorize this. It's easy to remember if you remember the slope formula, right? So let's do some examples. First example. Let's look at y minus 2 equals 3 times x minus 1. I know it's linear because I have two variables, x and y, and they're both to the first power. And I stare at it for a minute, and I compare it with the equation above, and I say, oh, this looks like the point slope form. So let's write down what the components are. The slope in this case, well, what's in front of the parentheses is a 3, so m is equal to 3. And the point, my x comma y, notice this minus sign. So I've got a minus sign and a minus sign, so that's good. So I'm subtracting y1. So I'm subtracting a 2. So remember, it's an ordered pair, x and y, so there'll be a 2 here for y. And then again, I've got a minus sign here. They line up, and so x1 is simply 1. So there's my point and the slope. And with this, we could easily draw a line. 1, 1, 2. There's a point, and my slope is 1, 2, 3, 1. and I get a nice little sketch of a line pretty quickly with this form. Let's try another one. Y plus 1 is equal to minus 2 x minus 3. Now I don't have the negative sign in front of y. Right, so the y-coordinate of the point is not 1, it's something else. So I need to rewrite this so that it looks like my equation here. Right, it needs to be in that form, so I need y minus, how am I going to get a plus 1? There we go. Remember this? A minus minus gives me a plus. Minus 2 x minus 3. So the slope is easy, right? It's minus 2. The point gets a little bit more complicated because of these minus signs. So my x value here is minus 3. I have a minus and a minus, so x is going to be 3. And here I've got the minus of minus 1. So I'm constantly comparing it to this equation. Y minus y1 is equal to m x minus x1. And these values, this is x1 comma y1. Good. Let's try one more. Let's look at y minus 2 is equal to minus x plus 3. I'd like you to pause the video now and come up with the point and the slope for this. Alright, so you have the point and the slope. What I would do is I would rearrange this, x minus 2. This minus with the parentheses, remember this is like a minus 1 times x. I want a negative here. I want to subtract x minus a minus 3. If I rewrite it like this, everything lines up. And I get my slope was minus 1, and my point was minus 3 comma 2. Good. Alright, so this was our third form of the equation of a line. In the next video, I'll show you how these three forms are related.